Hello, Professor. So I'm gonna read the question real fast. It says the length of a rectangle is increasing at a rate of 4 centimeters per square, and its width is decreasing at a rate of 3 centimeters per square. How fast is the area of the rectangle changing when the length is 20 centimeters and the width is 10 centimeters? So I'm gonna use my highlighter. I do know that the length of the rectangle is increasing. So the length of the rectangle is increasing at a rate of 4 centimeters per square, and its width is decreasing at a rate of 3 centimeters per square. How fast is the area of the rectangle changing when the length is 20 centimeters and the width is 10 centimeters? So, we talk about the area of the rectangle changing when the length is 20 centimeters and the width is 10 centimeters. Okay, so I'm gonna draw a picture of this. I'm gonna draw a rectangle, and I'm gonna draw the length and the width. Now we know that the length it has 20 centimeters and the width has 10 centimeters. Now, how fast is the area of the rectangle changing? So it could either be like decreasing changing or increasing changing. So my best guess would be we start off with d length, dl and dt. No wait, dt. And then that's gonna equal 4 centimeters. Where is it? Yeah, 4 centimeters. 4 centimeters per square. And then we put d width divided by dt, and that's gonna be 3 centimeters per square. So now that we know that 4 and 3, now that we know the length is 4 centimeters and the derivative for the length is 3 centimeters, we're gonna find our equation. So that's what we know. Now we're gonna find our equation, which is a equals 9 times width, and then we take the derivatives. Yeah, I'm sorry, I can't even say it. Take the derivatives. I don't know how to spell it. Derivatives. My English skills are not there yet. And then so yeah, let's start off with dt. dt is where is it? A equals dt with lw, yeah, meaning dt area, dt length and width. So dA, so now that this we can't, so dt and a do not match, so now we have to combine them together like how you always say. So dt equals the length dw and dt plus the width of the dl plus dt. Okay, so the next part would be what's the next part? I'm trying to remember. So dA, dw, and dl. Oh yeah. So we find, now we plug them in. So the length and the width. So when we plug it in, we would say it's gonna be dA dt 20 centimeters for the length. 20 centimeters, and then we multiply that by a 3, but since it's decreasing, we're gonna multiply it by a -3 centimeters per second, sorry. And then we add the width, which is where is it, 10 centimeters, and then we multiply that by 4 centimeters, but this one's positive because it's increasing per square. And now that we have that, we go back down to dA dt, and then we put, basically just multitap, we do the math. So we do 20 times negative 3 is a negative 60 centimeters per square, plus 10 centimeters plus 40, it's 40 centimeters per square. Now, if we do the math here, that's gonna be dA dt equals negative 20 centimeters per square. But we also have to put a what is it called? Not a cubic. It's I can't even say it. For some reason I can't say it, Professor. What is it? A square root. God, I'm forgetting these. Square root, I think it's called. Yeah, square root. So it's so my final answer is gonna be here. I'm gonna highlight it with blue. This is gonna be my final answer. And then my units are gonna be centimeters square per second. Yeah, cm2 per second. Yeah. And then I'm gonna write my sentence. So give my final answer as a complete sentence with correct units. And so I'm gonna say how fast is the area of the rectangle changing? The area of the rectangle changing when the length is 20 centimeters and the width is 10 centimeters. The area is dA dt equals 20 centimeters square per second. So how fast is the area of the rectangle? So since it's a negative 20, I would say that it's not going fast. I feel like I would say it's going slow. So I'm gonna put that instead of going fast, it's going slow. And just because of the decreasing rate of 3 centimeters, if it was obviously a width of is increasing, it would be faster, but it's not. There's a negative on that 3 because of that decreasing. So I would say that yeah, it's pretty slow, or it's not going at all because it's below 0. But yeah, I got the answer, negative 20 centimeters square, and yes. Here, and I'm gonna show you, Professor. Okay, thank you.